Participants? Anybody is working in this group?
Some are sharing in the chat box.
Oh, they are sharing in the chat. You can on your mic and tell me. You can on the mic and tell me, sir. Anyone?
Am I audible, ma'am?
Yes, I am audible. I am audible to you.
Okay.
Sir, I will tell
Yes,
randomly. Shanti madam can speak.
Hello.
Who is that? Durgesh. Durgesh, you are audible. Please tell me.
Yeah. Thank you so much, ma'am. Good afternoon, everyone. So this is Professor Durgesh Kshirsagar. Actually, I don't have any such experience with working on the electric vehicles.
Okay.
But definitely, I'm much more interested in knowing more in detail about this particular domain.
Very good, excellent. So I will give some light on electric vehicle, which will be an interesting area. Am I right?
Yes, ma'am. Yes, ma'am. Yes.
I gave yesterday some inputs on how IoT can be deployed for PQ monitoring. Yes, I was able to give you essence, right?
Yes.
The existing traditional grid is unidirectional, but when you move to smart grid, lot of power electronic components will be coming into the picture. So power quality problems will arise. Am I right? So it becomes very much mandatory to monitor the power quality. So this IoT is a tool to monitor and assess the power quality. Okay. So this is the carry-over message yesterday I passed on, right? So today I will be giving you a case study how IoT is used to monitor the power quality. That is number one. Number two, I thought today I will give an interesting topic on battery management system. Most of the electric vehicles, now what you can tell, battery is very essential in an electric vehicle. Hope you will all agree with me. Next to motors, electric motors and batteries are the need of the hour, right? And how IoT can play a vital role in monitoring the battery status. Okay. So Durgesh can interact with me because he is a volunteer today. Durgesh, what is your feedback? You said you are not working much on electric vehicle, but you will be excited to work on electric vehicle. So let me start from this electric vehicle first. As you all see, India, we are trying to march towards electric vehicle penetration. Maybe by 2025, we will be having lot of electric vehicles pumped into the distribution network. We have come out with FAME 2 policy, and being from Tamil Nadu, there is also a electric vehicle policy launched for the state of Tamil Nadu. So in that, what they have told is vehicles are going to come and government is going to give lot of subsidies. So if you take electric vehicles, you classify them into 4 categories: 2-wheelers, 3-wheelers, 4-wheelers, trucks and buses, right? And in 80% of the population depends on 2-wheelers and 3-wheelers. Hope you will agree with me, right? There are 2 scenarios, pre-COVID and post-COVID. Pre-COVID, yes, there are a lot of vehicles where there people are focusing, but after the scenario of post-COVID situation, what we are facing now, electric bikes are gaining more momentum. Why? Because we are afraid to travel in the buses or in the trains or etc., or even in the Ola cabs. Hope you must agree with my statement, right? There is the safety of the life is very, very significant and important. So for short distance and for easy connectivity, electric bikes are going to gain lot of momentum. And I also got a project sanctioned on electric vehicle, smart charging of electric vehicle stations, right? I mean to say smart meaning I'm going to connect the IoT sensors and I'm going to monitor the battery status, and I also want to track the vehicle where it is and where is the next charging kiosk available, right? So these are all my intentions, and I was given one small funding from RPS. So I must thank AICT for giving the funding. So anybody interested in this group can also contact me for further. We can all work together because it's a seed money given to me, meaning that you can also participate and we can publish together many papers, right? So let me go on to the topic of IoT based battery management system for electric vehicle application. I'm talking with respect to EV today because EV is going to pick up a lot of momentum, and by 2025 I'm very sure a lot of vehicles will be coming into the system. Whereas when you compare with the two-wheelers and three-wheelers, four-wheelers is a luxury segment and the cost is a little bit very high. But I don't mean that it will not come. It will also come. But the 80% majority of the population will be using the two-wheelers and the three-wheelers, especially in the electric vehicle domain. So in that, if you see, battery is going to form the most essential component of any vehicle. So what is that meaning? Why battery I'm talking? Because you have to maintain the battery to a very good health wise and the functioning wise. You have to properly manage the battery. So a perfect maintenance of the battery is very essential for it to function properly. Why we are talking about the BMS for the battery? Because your present scenario, we are having our microgrids or renewable energy based systems, but all the renewable energy based systems also needs storage, right? So yesterday we discussed about microgrids and smart grids. Even in the smart microgrid also you need a battery system. Why? Because that is going to become a backup energy source, so that will deliver the stored energy whenever the main energy producer does not produce energy. If you take the solar and the wind, they are not going to be perennially available. Solar is diurnal, it will available only during the daytime, and wind is only seasonal. And if you take it is a 4 months only wind is surplus in our state Tamil Nadu, that is June, July, August, September. So only this month, till this month end, we will be having a surplus wind flow. But after September, if you see, the wind will not be of that much high wind speeds will not be available. Even in the 3 belts which I was discussing yesterday, we were discussing 3 belts are there in Tamil Nadu, which are prone to or which are very good for wind regions, you can call it. So there are wind resource assessment stations deployed in Kayatharu for monitoring these things, and there are also solar resource assessment stations deployed in the state of Tamil Nadu, especially in Chennai. You have 6 locations for monitoring and assessing how much is the available irradiation with respect to solar and with respect to wind also, what is available, wind speed available. People have created a very good database. So it clearly says that both the renewable energy sources are not perennial. So you need to match a proper balance between the solar and the wind as well as on the biomass, so that you become a continuous source. So, but that is not possible. So what you do, whenever wind is there, whenever solar is there, whenever biomass is there, you try to store the energy onto a battery. I'm trying to relate why battery is very significant with respect to microgrid as well as in electric vehicles. I started with electric vehicle, now I'm just taking you back to smart grids environment, and everywhere if you see, battery is going to play a vital role. And whenever battery comes into picture, you need to work on battery management system. Why? Because battery management system has to be enhanced in order to provide a better performance. Hope you will agree with my statement. So that you need to develop a battery monitoring system, and that monitoring system is going to be an integral part of BMS, which will be monitoring the operational system, performance and battery life, such that your charge and discharge process will be exactly assessed through the help of battery monitoring system. And how IoT is going to play with the battery monitoring system, that is my intention. I will be telling in the coming slides. So hope you got my idea. So batteries are going to be an essential component in electric vehicle as well as in microgrid environment. Why? Because you need to produce energy continuously. So whenever there is surplus of energy, you store it into battery and you try to take the energy back from the battery to the system. So battery monitoring system is actually going to consist of measuring devices. These measuring devices are nothing but your IoT sensors, and they will be measuring the parameters such as battery voltage, your current and temperature. So please note down, there are 3 parameters you will be noting in the electric vehicle application. Number 1, you will be noting down the voltage, you will be noting down the current and the temperature. So after noting down, what are you going to do with these 3 parameters? These parameters has to be processed so that you will be estimating the state of charge, that is called as SOC. So that is a very important parameter in the BMS. Next parameter is called the state of health of the battery. You call it as SOH. Okay. There are several methods to calculate these parameters. Okay. But these methods cannot provide correct results. Why? Because the battery materials and atmosphere surrounding the battery and what is the load put on the battery is going to affect these two important parameters. What are the two important parameters? SOC and SOH, right? How now in IoT will come into play? This Internet of Things is going to enable your smart microgrid to share the information for more users, and it is going to enhance the connectivity throughout many infrastructures, right? So that is the role of IoT, right? Now the problem is we need to monitor the two important parameters. What are those? SOC and SOH. For doing that, we are taking the help of IoT. So at the end of my lecture, definitely you can do some mini projects to start with immediately, and you can give the performance, right? So once again, Shanmugam, any doubt? One minute, just. என்னாச்சு HOD சார் அந்த கம்ப்யூட்டர் வேணுமா?
அவர் யூஸ் பண்றாங்க. நம்ம யூஸ் பண்ற சிஸ்டம்.
யார் HOD சார் யூஸ் பண்றாங்க?
HOD சார் யூஸ் பண்ணிருக்க சொல்லி கேட்டாங்க.
யார் பையனா?
ஆமா.
இத மட்டும் முடிச்சறேன்னு சொல்றாங்க. பட் கம்பேரிசன்.
அது கம்பேரிசன்
பண்ணிட்டு இருக்கியா? Thank you, சூப்பர்.
அசோசியேட் தானே?
ஆமா, அசோசியேட் தான். Associate professor bar professor in /professor in charge அந்த லெட்டர்ல அப்படி இருக்கணுமே. professor in charge போட்டுறாங்க. அது கேட்டவர். associate professor /professor in charge. professor in charge primi professor டைப் பண்ணு.
primi professor in charge. ஓகே.
அவட்ட டைம் கேட்டு கொஞ்சம் இது பண்ணிடு.
சரி. இது ஒண்ணு இது அது ஒர்க் இருக்காரு. அது சொன்னா நான் உட்கார்ந்து.
Okay. Sorry for the interruption. Like some doubts were there. Being in college now, we need to very sorry. So let's resume back. So I have told two important parameters, SOC and SOH. So you are going to take the help of IoT. At least this is clear for you. So with that understanding, let me move on to IoT. This IoT is called as the fourth generation of supervisory control and data acquisition system. There's nothing but called as SCADA, right? So IoT actually does the process called as SCADA only. And what does a SCADA does normally? It is going to monitor and control, and it will also communicate through an internet gateway. That is what going to be done with the help of IoT. Then it will also take the help of cloud, right? So cloud system is going to be a best partner for the data storage for IoT. So yesterday I started telling that there are 4 components that I also mentioned about cloud. Today we will be seeing how exactly all the things are put forth. Okay, so you need an IoT. You need a good cloud storage, right? This cloud system is going to be a third party. It can be owned by any third party only. Why? Because we need to use the third party for a database which is going to transfer the data over the internet gateway. So now I am giving a lecture to you. For this also you need a good internet connectivity. Am I right or wrong? If there is no going to be any stoppage in my lecture, maybe the internet is not working, you will not be able to get it connected. Any doubts? Somebody is talking. Any doubts? Pranita madam? Pranita. Okay. Durgesh, are you getting my point? What I'm trying to tell? Sundarajan sir? I'm just seeing your name so that I want to make it as an interactive session today. Not like yesterday. Today you all have to definitely ask me some questions. See, there are two things. If you don't understand, you will not ask any questions. Either if you understand completely, you will not ask questions. Because I didn't know yesterday, nobody were asking me any of the questions. Today I want each and everyone. There are 51 participants I could see here. I wish at least 10% of the people are at least throwing some valuable questions which I can share from my experience. Okay? So let's go back to our presentation. Right. So we are going to take the help of these two things, right? One is the cloud, another guy is going to be the IoT. So this the advantage of the cloud system is going to be they are going to have large data storage and they are going to have high reliability as well as they should be of low cost, okay, and should have an excellent scalability that can handle growing amount of the work, whatever we are going to do, okay. So cloud system basically will going to benefit the industries because it is going to reduce the cost of the data storage facilities, and extra maintenance also cost will also be reduced because you're going to put it on the cloud. You're going to pay monthly rent like your whatever you're paying for your charging your cell phones. So the cloud will be owned by some third party and you will be taking their space to put all these data. With the data in the cloud, users can easily process and also do the analysis so that the data accurately anywhere in the system can be easily accountable, and you can do the process. And because of the large data stored in the cloud, you can make faster decisions, right? Even when you go to a doctor, what does a doctor does? He asks you to do certain tests. What does the test results say you? That your health conditions of your human body, right? So based on the test reports, he's able to identify or diagnose what is the problem in you. Similar manner, the more the data is available, and when you put it onto the what do you call the cloud, it becomes very easy for you, right? So with respect to battery, if you take, sometimes the battery should not, many times the battery should not get into overcharging mode, right? Overcharging of the battery will lead to emission of gases like hydrogen and oxygen, which are not good for the environment, because of the post-COVID situations. What has happened? The global warming has come down drastically, right? And the nature has got its self-healing because of the post-COVID situations, right? We have not operated any of the vehicles, so pollution is very less. So the hole in the ozone layer has actually come down. People say like that, right? And in one way, if you see, these lockdowns are very helpful because the pollution is very less now when compared to the earlier times. We had taken, the nature has given a huge break. This is one side. I'm talking only the positive aspects of post-COVID, but on another side, it is alarming. You all will agree with me, right? This deadly disease should never come to country like us because it is very, very challenging. And we being a developing country, any calamity is very, very challenging to give attention to the public because our population is very, very high. Now, if you see, we are now in the second position in the COVID situation. So I wish the God will help us and shower all his blessings so that this COVID situation will completely change in the coming days. Okay, let's move back to the IoT. So there are been this IoT deployed and you try to use it in the transportation and logistics. For example, if you take in your home or office or any plant, you can put these things very well so that you will be able to monitor or have a kind of a visualization of the energy consumption happening in the real time. Okay, so this is again another advantage of using IoT. And if you take in the smart grid environment, it becomes how much is the energy being consumed. That is will also be monitored using IoT. So definitely this is going to help in the load management along with the smart loads deployed. So a battery monitoring and protection system has to be developed, and that is going to do the process of exactly assessing the battery capacity level, like the state of charge and the state of health. So BMS, finally what I can tell is, BMS is designed or it is made to do the objective of detecting the emission of these gases from the battery when it is overcharged, as well as it will monitor the three basic parameters. They are the voltage, current and the temperature. For this, I have used STM controller and sensors. You can use any controller. There are low-cost controllers also available, PIC and Raspberry Pi, etc., etc. You can do any of the controllers and write a small logic so that you can monitor. And whatever my objective is to monitor the overcharging. And because when you overcharge, I said the release of gases are happening, so the battery should never get overcharged. Even if you take your mobile phone, you cannot put the mobile phone for charging overnight. What will happen end of the day? The battery will bulge and the life of the battery will come down. So never the battery should be overcharged, as well as it should not be deep discharged. So that's why they tell, no, when the battery is low, people will tell don't talk. If the radiation effect is very high, there is another drawback. It will affect your human ears, right? So similar manner, whenever batteries are coming into picture, you should never allow the battery to get overcharged or deep discharge. That means you have to maintain the state of the charge of the battery always based on the prescription or based on the manufacturing level, right? So now what I'm going to equip is I'm going to take a GPS module. Why I'm taking a GPS module means this will track my vehicles. So GPS will definitely clearly tell me where my vehicle is moving. So all these values, I'm going to take it to the cloud and I'm going to bring the concept of IoT, Internet of Things. Yesterday I was talking only IoT. Now I'm going to today demonstrate what we really did for BMS. And I want to also say that we have written a chapter in a book recently published in very good publications, Scrivener publications. you can refer that. You can put my name, Dr. it's a chapter edited by, contributed by me. And the authors are from Denmark, Dr. Sanjeevi Kumar Padmanabhan, then Dr. Himawati and Dr. Chitra from VAT, and Dr. Himawati was from Pondicherry Engineering College. They have written or they have edited a book. In that book, I have also contributed a chapter called IoT based battery monitoring system. For further understanding, you can also refer that chapter so that you will get some idea and you guys can really implement a kind of a IoT maybe at the end of the workshop. So that is how I feel this workshop should have facilitated you and would have motivated you for doing your research, because most of the faculties will be aspiring to do PhD. I hope you will all agree with my statement, right? If not, please have a positive thought, and if you have not completed your PhD, try to take a PhD. And this area is a very emerging area, and you need to deploy IoTs, right? So that you are easily able to manage the system with ease and with a flexibility, right? I also told yesterday, even in a hospital in Coimbatore has also employed IoT based health monitoring system. So for the patient who is very much located in an ICU ward or in a critical conditions, there will be a proper, the IoT will help the patient to monitor effectively. Why? Because what time the medicines are given, what food the patients are given, and what time the nurses are taking care of the patient, and what is the heart rate, what is the BP level, etc., oxygen level, etc. Everything can be easily monitored and assessed with the help of IoT, and the doctor can sit at its room and do some kind of a manipulation so that he can give a proper treatment at the right time, so that the person is getting a improved health life when compared to the normal life. So IoT is playing a very good role, and in one of the hospitals successful, I think Hindu hospital or something, I don't remember the name, they have successfully deployed the IoT based smart hospital management system. They have developed it. So that is one example. So after this lecture, at least you try to visit some places who are all doing IoTs, so that you can relate that whatever we discussed in the 5 days can be made it as a practical, approachable thing, so that you can also do it at your destination in your respective colleges. Okay. So the central module will be directly connected to the HDMI display, and also remote desktop access will be given, so that the user interface can be done with the help of communication protocol. So the BMS was developed as a central module to monitor and the performance of the batteries located in the electric vehicles, right? So due to the advancement of the design of notification system, IoT is very, very, very vital in notifying the manufacturer and the users regarding the battery status, right? So you need to tell the status of the battery, because that only will help you to take the vehicle for either 25-kilometer drive or 45-kilometer drive, right? For one charge, it should give minimum whatever the standard says, right? For one charge, complete charge, the vehicle go for 45 kilometers. I'm talking about electric bikes, right? If they are 25 to 30 kilometer means that exactly should come. But during the travel, if it is not going to come 25 kilometer, and if IoT is going to be connected, you will be able to know what is the state of charge. So based on which you can find out which is the next charging station nearby, and go and put your two-wheeler or the electric bike to the charging station, so that your hassle-free is made possible, right? Suppose you're going to go for the drive using electric vehicle, and if your state of charge is going to come down and you're not able to locate any charging station or charging kiosk, your life will become very miserable, right? Because this vehicle is a newly developed electric vehicle running purely on an electric motor and a battery. So if that is the case, unless you have a swapping kind of a technology, and that is more apt for these kind of a two-wheelers and three-wheelers. That is what the study says. But this may not be a viable solution for four-wheelers. Why? Because the cost of the vehicle is very, very important. See, if you take today the Kona and other models are not gaining very big momentum, because the model of the cars are very expensive and it cannot be affordable by the common public, right? So everybody should be affordable means you need to develop a cost-effective mechanism made in India product, so that people are going to utilize it, right? So what I finally want to tell is the maintenance support procedure that can be done only by the manufacturer. So IoT is actually going to use the internet connectivity beyond your traditional application, where diverse range of devices and everyday things can be connected via the internet, making the world at the fingertip of the person, right? So this is possible with the help of internet and the IoT, right? So now let us move on to the communication aspects. What are the technologies based on wireless communication? Sir, here if wireless communication, if you take, it is a type of data communication that is performed and delivered wirelessly. So that you must remember, understand, it is going to be doing in wireless mode. Okay. So there is a broad term that is going to incorporate all your procedures, and it's going to form a connecting and communication medium between two or more devices using a wireless signal through wireless communication technologies and devices. So earlier what people have done is they have done the battery, so-called battery management system with the help of a wireless mode. So they were using either GSM or Zigbee or GPRS or Android or Wi-Fi and Bluetooth communication. These are the several types of technology that were already available for wireless battery management system. So anything you can take it. Let us see one by one. What is GSM? GM stands for Global System for Mobile Communication, right? And it is a type of wireless communication that is very popular worldwide, right? It is frequency based in either 900 megahertz or 1800 megahertz. So this is the frequency range of your GSM. So there are certain advantages as well as disadvantages of the GSM module. What are the advantages if you take? The advantage of GSM is that there is no problem with international roaming. So this is very, very important, right? It is also easy to implement, and the global subscribers create much better in the network effect for GSM handset makers, carriers and users. So most of the technology what we are seeing are patented and should have a license from either from Qualcomm Corporation. Okay, so this is the background behind our GSM based wireless communication. There are many literatures available on battery monitoring and management. So please go through it. I have collected few papers. I'll be sharing with you all. You can go through it and revert to me for any doubts or difficulties, right? So GSM, the frequency band of the GSM is 900 Hertz to 1800 megahertz. So I hope you're clear with the GSM, right? Let us move on to the next one. We have finished GSM. Now what will be the next one? GPS. So this GPS is a very interesting guy. Why? Because if you take these Olas and other Uber and other taxis, they are actually connected via GPS only. So I will share one of my very good experience I had in when I was moving around Singapore. Right, the drivers of the public taxis, are always monitored by the government of Singapore and regarding their speed, what speed they are traveling, and whether they are able to give the balance amount for travel, right? So if we take $10, the amount you are giving to a driver, but the cost of the travel was only $9.65 means the driver's duty is to return the $0.45 back. I was so surprised. He returned the dollars to me, Singapore dollars to me back. He never took not even 1 cent extra. So why? Because he said to me that I am monitored by the battery monitoring system, and that will quickly go on and indicate that I have given something or taken something. So that is how the GPS are very, very vital, right? So the signals moving at the speed of the light will be arriving at the GPS receiver, so that at slightly different time, because some satellites are further away from others. So that is why you get some slight difference in that time, right? The global positioning system normally utilizes the GPS satellite to transmit the data that is going to provide location and current to a GPS receiver globally. It synchronizes the operation so that these corresponding signals transmitted at the same instant, right? So, however, the distance of the GPS satellites can be determined by estimating the amount of time, okay? We have to actually estimate the amount of time that is going to take for the signals to reach the receiver. When the receiver estimates the distance of the least 4 GPS satellites, it can conclude that it is going to be the position in the 3 dimensions, right? So the accuracy of a position is going to be determined with the help of GPS, and that is going to depend on the type of the receiver, right? Most consumer GPS units have an accuracy of about plus or minus 10 meters, right? So other types of receivers are also there, but they are going to use a different method called differential GPS to obtain much higher accuracy, right? So this is with respect to GPS. Now we move on to the how this GPS or GPRS is going to be deployed for the EV application. So when you take that, here there is going to be an interesting guy called EV based on GPRS. And what is a GPRS? It is nothing but it is a communication. GPS communication consists of online monitoring to measure the battery parameters, right? The voltage and the current, and GPS transmitted to add a user interface for battery monitoring. So there's a paper written by Rahman et al. And he has proposed a BMS for EVs using Zigbee communication and also a point-to-point wireless topology. I'll also tell what is the name of the paper fully, and it can be also shared in the Google Drive to all the participants. So that is also going to play a very vital role in estimating the battery status, right? So the Zigbee will be used to due to its low power consumption. Why do they prefer Zigbee? Because Zigbees are low cost devices and they are having high reliability, and the data transfer is low only, but still being the cost and the consumption level, it is going to be less, right? So they concluded that the wireless battery management system is important EV for the EVs mainly to balance the cell as well as your other parameters in the battery, and you can also enhance the lifespan, so that it will be a very good system for our electric vehicle applications, right? So, but this may not be viable or very efficient for controlling the battery temperature, right? So, to enhance the battery life by giving more what do you call exercise, you will be able to have a better life of the battery. Right, let us quickly see a methodology of it, how I'm going to do it. So let me show a lithium ion battery in the picture. So this will be connected via your sensors, voltage sensors, right? So lithium ion battery will be connected with the help of voltage sensors, and the information will be passed through to the Arduino Uno board, and that information after processing will be entering as a process signal into the SIM 808 GSM or GPRS or G Shield. So this will be of great support, so that we are able to monitor what is happening in the case of a batteries, right? So that then this GPS or GPRS or GSM will be connected to the internet via a wireless medium also. Then one more thing is, you can also have a monitoring interface embedded in the system, so that what is happening can be easily understood, right? So let us move on to the further understanding of I hope this idea is clear about the BMS. So one more aspect I want to tell is this battery management system will definitely help in monitoring the system voltage, temperature and current. So the IED actually provided is SMACOM, which is a proprietary serial communication to communicate from and to the LED light emitting diode, and is going to provide TCP/IP communication with JSON format as an open communication protocol. Okay, so now I think you would have got some idea about what is BMS and how exactly the parameters you are going to monitor in the BMS. So quickly recap means you are going to monitor the voltage, current and the temperature of the battery. Thereby you are going to prevent the overcharging of the battery. Why? Because that is going to affect the performance. And similarly, you will also be monitoring very two important parameters, that's nothing but called state of health and state of charge. Okay, so what we try to say now as in a nutshell is IoT based monitoring system is developed, which consists of a communication channel from and to the LED, and there's going to be a data acquisition, and there's going to be also a cloud system, and there's going to be of a human machine interface, right? So we will be deploying an embedded system that will be put into the system. So what is the use of this embedded system? This is developed as an IoT to provide the communication from and to the LED as a data acquisition and as an internet gateway for all the battery system parameters, such that battery is going to really enhance the life of the battery. Thereby, you are able to store or process or do whatever things you want can be done very well using this kind of a IoT based system also, right? So the IoT based monitoring system utilizes the digital communication, right? Am I right or wrong? It is basically utilizing it is going to utilize the properly the BMS, so that you will be able to have a better monitoring system developed. And for communication, you can also use TCP/IP or JSON format, which is going to help in the fast data acquisition as well as to retrieve the battery measurement parameter from the so-called IEDs. IEDs are nothing but intelligent electronic devices. Okay, so after getting all these things done, now you will be getting some voluminous amount of data, right? Because of that purpose, these data cannot be sent to a local server, and you cannot tell tomorrow I cannot come and process the data because of some lockdown or any other situation, right? People will try to escape. So what they are told, you do the data or whatever may be possible, please do it at your destination end, right? So due to the data is sent to the database, and web server on the cloud system will be done via the internet gate. The data is in the cloud system is going to be processed and analyzed, and it's going to be produced your information, which can be understood easily by users as it is deployed in human machine interface, right? HTML downloads what HTML actually HTML framework, which can be accessed using desktop or mobile devices or Excel per the diagram shown here. So there is also in the process you do it, right? So what we do the measurement of voltage, current and temperature. That is done in the battery pack. I'm quickly recalling. Then you're passing the information on to the intelligent electronic device. From the intelligent electronic device, you're connecting to the BMS based IoT. Then you try to improvise and put it across, and so that you are going to transfer your data at this place, so that the excess data will be folded and kept in the computer, right? So this is what about the BMS system based on IoT. Now let me move on to the IoT itself. IoT, what exactly IoT I want to do is, I am going to have an embedded system that is going to utilize the IoT in this particular work. You can also use Raspberry Pi model too, whose primary function is to execute your data acquisition and as an internet gateway to the cloud server. So you will be writing one data acquisition algorithm which will be embedded onto the embedded software, so that you can easily implement using PHP server side from programming that will execute two main programs. One is the battery management system, and also the second one is going to be the PV monitoring system. We totally forgot about PV monitoring. So when you connect the PV with this, some of the batteries which we discussed right now, it will be a very big boon to the country. Why? Because the generated power from solar is going to be a DC, and if you avoid transformations from one person to another, finally what will happen? You may get not the desired amount. You may get a very less quantity than the sanctioned amount, right? So that is what we try to tell again and again. So let us see what exactly the primary function is done in the internet gateway. So the data acquisition algorithm in the embedded system is actually implemented using will be used effectively, so that what is happening is there will be two programs running parallelly. One is called the battery management system, and next one is the photovoltaic monitoring system, which I completely forgot. This charging station which we are talking will be powered via solar. So 50% will be able to be taken from the EB supply only. So that is very, very important for you to understand, right? So the embedded system will restart for every 3 hours, and you are going to optimize the system operation, right? System execution. As far as the IoT interface, as far as the IoT internet gateway, an embedded system, or embedded digital subscriber line, ADSL, will be provided, or will be the provider which will download the speed as 1024 kilometer per second. Okay, so that is going to upload the data to the cloud server. So these databases will help us in definitely quantifying or assessing the problems in the system. So for my lecture, I have utilized actually a paper published in the year 2017 itself by there's a set of members in the IEEE, that those members will be working on this kind of a BMS system, right? So with that, I will try to take you to a better understanding of how BMS system based on IoT is done. So IoT based battery monitoring system was developed in continuation with the communication channel, so that your communication can happen between to and fro, and also through LED. This is what the BMS on based on IoT does. So basically, what it does, let me recall once again. IoT based BMS is developed, which is going to do the process of communication channel from and to the IED. IED is that I told you what is IED, and also it is going to do the data acquisition and also cloud, and it is going to also use it using human machine interface. So the embedded system has been developed as an IoT to provide the what do you call? It is going to provide a communication to and fro from the IED, and thereby a data acquisition and an internet gateway will all follow, so that all these parameters will be easily accountable, such as communication provider, and it is also going to be a you'll process all the data, and also it can be accessed further these parameters from the cloud platform. Okay, so that is what the understanding about IoT based BMS. So the IoT based BMS is going to differ from the existing one. Why? Because it is going to have a digital communication, TCP, IP, and JSON format for data acquisition to retrieve the battery management parameter from the IED, intelligent electronic device. Data is sent to the database, and thereby the web server on the cloud system via the internet gateway will be chosen. The data stored in the cloud will actually be processed and analyzed to produce information which will be actually understood, so that it will help the users, and it will be a very good significant role in our day-to-day life, right? So this is how the battery monitoring system of IoT will be done. Okay, so this Internet of Things will become very, very vital, and we'll be using them in our proper studies. So what will be the end result when I use the data acquisition cards? There will be going to be a voluminous amount of data. So when you take the average, what will happen is it will try to give or take accordingly to it. So this is how it is being done in the system scenario, right? With that, I move on back to my power quality itself presentation. So yesterday we saw this. I hope you are clear with what is power quality. Power quality, I'll recap quickly. Power quality is a product of voltage quality into current quality, but current quality is no longer under my control. So voltage quality is only under my control. So we are trying to enhance the voltage quality, thereby the current quality, whatever it was good only, will be still continuing. But sometimes the poor voltage quality will also affect the neighboring system, and they may have a reduction in the supply or something else like that, right? So we saw why power quality is significant, and we also saw introduction to power quality. So these are all the symptoms, right? So lights will be blinking. When lights are blinking, you should not tell lights are blinking. It's actually voltage is flickering. Sustained low voltage happening in the period of less than 25 hertz, then you call it as light is going to blink or flicker. Sudden equipment and malfunction, sudden tripping of circuit breakers, premature equipment of your equipment or your failure, then your poor performance and unexpected shutdowns. Lost data in electronics is going to be gained, and that will determine the system performance. Lost data in electronics will be got, and there is going to be a leakage current which is high in nature as well as the workshop, right? The others, I am talking about the others, right? So why power quality is in use? I told you this also because of the world demand is growing and lot of penetration of renewable energy and electric vehicle charging infrastructure. In the coming days, power quality is going to be a significant topic, and you guys can do a good research in the coming days. So these PQ disturbances are of increasing concern due to widespread of the usage of power electronics. So I told you, the one who takes sword will die with the help of sword. That is the proverb in Tamil. Katti eduthavanukku kattiyale savu. The problems were created by power electronics. So you have to get the solution from the same power electronics. That means you put the compensated devices. Yesterday we discussed briefly about the various compensated devices. Hope you recall it. One is the D-STATCOM used for shunt related issues, and the second one is the DVR which is related with the second issues. So like that it goes on, right? So it is the duty of the system to take care of the power quality at a very stringent level. So presently what we do is we are using for PQ disturbance detection, and this itself is finding a widespread use of power electronic equipment in industrial and commercial buildings, right? So this is the IEEE 1159 clearly tells you how to monitor electric power quality. So that is a very, very good textbook for how to monitor, good standard, not a textbook, good standard for monitoring the electric power quality. Okay, so let me show one small video today also in explaining the significance. I hope the audio will be clear to you. If not, I will try to take it up as a, what do you call? You please tell me whether audio is clear or not. Otherwise, I will pass the slide to the organizer so that he can be able to help you out in listening to it, right? Once again, there is going to be the video on the topic. Once again, okay. So please watch this video. It is a very interesting video on how you are actually using the power quality analyzer to capture these results, right? So you need to have a good class A equipment for capturing the power quality events. So that will help you to what do you call, assess the power quality disturbances. Power quality disturbances are varying in nature. So you need to really quantify them so that your problems will be resolved, right? Let us see this video. So in market, if you see, there are class A, class B and class S equipments. So the most viable equipment is class A equipment. You all have to use it because that is a important one. So I kept the volume also high.
It's marvelous, but mysterious. And because it runs just about everything in your plant, it's also one of your major costs. Poor power quality has become one of the most serious issues in industrial facilities and one of the most untapped areas of cost reduction and economic advantage. The Electric Power Research Institute estimates that poor power quality costs American industry up to $188 billion a year in direct costs, as well as lost productivity. That's equivalent to the budgets of Ohio, Michigan, Indiana, and Wisconsin put together. In fact, there isn't another cost reduction potential in industrial plants that comes close to this staggering total. And what's more alarming is that industry studies have shown about 80% of this number, $150 billion a year, is caused not by power quality from your electric utility, but by self-induced problems inside your facility, the vast majority of which can be diagnosed and corrected. Power problems aren't new, but they've almost always been either misunderstood, mismanaged, or ignored. For most, unless you're an electrical engineer, power terms and their associated problems such as harmonics, swells, power factor, and more can be a mystery. Symptoms of power quality problems occur randomly and always at the worst of times. You suffer through unplanned downtime caused by motors that mysteriously die, machine controllers that suddenly lose their programs or values, damaged drives, capacitors that short out, and more. And with more machinery being run by electrically sensitive equipment, such as VFD drives and computerized controls, the problems are accelerating, not diminishing. Because production is critical, those fatal components are often replaced instead of diagnosing and fixing the root cause, until it happens again again and again and again. Part replacements cost the store, and of course the lost production time is never recovered. This costly advance required an army of highly skilled electrical consultants, expensive specialized instrumentation, and capital appropriation through multiple approval levels. That all changes with the introduction of the Machine Sense Power Analyzer. This proven technology has been tested for 2 years with industrial users just like you. The result is the first affordable, easy to understand 24/7 power analyzer for non-electrical manufacturing professionals. It's priced thousands less than historic power instrumentation. Consider it an industrial MRI, a diagnosis under the covers of your wiring, your electrical distribution grid, and your powered machinery, so you can easily identify the internal power issues and get them fixed. Like an MRI, with Power Analyzer, you'll know what's really happening inside your control panels, inside the wires in your walls, and inside your drives. But unlike actual MRI diagnostics, you don't have to be an expert to read the results. Machine Sense electrical toroids are placed directly on incoming power lines or machine power lines to automatically monitor power conditions. This 24/7 collection of data transmits through an internal data hub directly to your room and is analyzed by cloud-based servers. Our crystal ball software automatically translates complicated electrical graphs into intuitive dashboards. Armed with this data, you can put together an action plan to tackle the biggest cost reduction opportunity and productivity enhancer in American industry today. We'll conquer poor power quality issues and achieve economic gains through reduced utility bills, lower downtimes, and improved productivity. And you'll avoid expensive part replacement as well. You'll realize a future with significantly reduced motor, drive, controller, and capacitor issues. You'll be rewarded with dramatically reduced unplanned downtime, lower utility bills, improved productivity and profitability. Your life just got a whole lot easier. With Machine Sense, the future of manufacturing is here.
Okay, this is one interesting paper. I hope you can all see the screen. But I'll make it as a bigger screen. I'll make it as a full screen for you all to see it. Oh, fit to the 1 voltage. Okay. This is a very nice paper. It was written in development of BMS smart microgrid based on Internet of Things. So please refer this paper. So if you see, you can develop something like this one. You can create one kind of a BMS like this, right? So you have a battery pack. So again, when I got to tell you about the different types of batteries used in electric vehicle. So if you take the 2-wheelers and 3-wheelers, LFP batteries are widely used. That is lithium iron phosphate. The next type of battery is lithium manganese cobalt. You call it as NMC. Sorry, nickel manganese cobalt. In this NMC batteries, this due to your exploration of illegal movement of your manganese and your cobalt, which is very exploding material also, that is not taking a wider leap. So LFP is becoming very popular in the present day, and LFP, lithium iron phosphate batteries can be easily deployable for the 2-wheelers and 3-wheeler applications, right? But out of this LFP and NMC, there are 4 more lithium ion family members, which are also good in energy density and power density for your application. So based on your application, you have to choose the right battery for your right application. So this is one diagrammatic representation of how exactly you can apply IoT for BMS, battery management system. So take the battery pack. You are going to, as I said to you, are going to monitor the voltage, current, and the temperature, and this will be done, and it will be taken care via this IED devices, intelligent electronic devices, using this protocol, TCP/IP JSON protocol. So this is then transported via the gateway, which is for internet gateway, which will transfer the data to the cloud. So from the cloud, you can either take to a mobile or to the computer, and thereby you can easily monitor the battery health. So you can also create one GUI, graphical user interface, to exactly tell about what is the state of charge, what is the state of health, etc., etc. So you could see here the state of charge is being monitored, and this HMI can be very well developed for the PMI, and you can write the necessary coding for it. So you can also develop a flowchart of how your algorithm is going to work, right? So this will create a kind of a revolution in your application. So what was this video we saw? Give you a message. There is a possibility to use your IoT very successfully for your data management, right? And battery management. So and health of the system, right? The video which I put was clearly telling you that if you have good data acquisition systems, you can collect the data and you can also monitor the health of the situation very well. So I think you saw this yesterday. So I'm going to skip this. So the introduction is also given to you. So all these power quality problems will be prevailing in the smart grid. So I'm going back to my smart grid environment. Why? Because we can see in detail how the power quality monitoring is done. So these two transformations are also very widely used in digital signal processing tool to monitor the power quality disturbances. Like Gabor and Wigner transform can be very well deployed for PQ monitoring. You can also use wavelets. This is also another important area. Those who are doing research, please apply these domains. There is also one more area called Kalman filtering, which we discussed yesterday. And there is also one more application area, S transformation. These things can Petri nets. So please use these keywords and start collecting some papers so that you can do a good research based on these methods, right? So these Gabor and Wigner are two scientists worked in laboratory, and they developed this transformation. It was actually named after Eugene Wigner and Gabor also. Both of them developed this transformation so that it was very well deployable for power quality disturbance detection. There is also one more tool which is called a support vector machine. This is also a very powerful tool for monitoring your PQ disturbances, right? So again, Hilbert also started working, and Hilbert also came with one more transformation called as Hilbert-Huang transform, where the power quality in the distribution network is considered to characterize the power signal disturbances, and thereby there are some hybrid transform based methods that are also developed to assess the PQ disturbances, right? So what basically these algorithms does means they will try to detect the disturbances and put it into the algorithm, and the algorithm will have some threshold values for each of the PQ disturbances. Suppose it is a sag means, what is the definition of sag? Any voltage lying between 0.1 per unit to 0.9 per unit. It is called voltage swell. What is voltage swell? Rise in the voltage from 1.1 to 1.9 per unit. These two are called as the definition of sag and swell. So you make one threshold. You try to pass the disturbance signal on to the algorithm, and in the algorithm you try to have a check for the standards, right? So anything below 1 per unit, and you check whether it is going below 0.1 per unit means it is something different. 0.1 to 0.9 per unit, if it is going to lie means, you clearly can identify and tell that it is a disturbance because of voltage sag. So I'm just giving an example how people are doing on it. So that is how you try to easily estimate the presence of the particular power quality disturbances, right? So Kalman filter is another important approach where you can actually do quickly the estimation of the true value, the position and the velocity. So you are going to estimate, initially your estimate error will be somewhere, but your actual will be in another place. So the difference is going to be the error. Your objective is to minimize the error, right? So we need to develop an excellent smart meter which is going to have a heterogeneous infrastructure, right? What do you mean by heterogeneous infrastructure? It should have a good communication network, it should have a very good data processing as well as management, and it should be easily installable, right? And for doing this, you need to provide at least a minimum infrastructure onto the system where you want to monitor the power quality, so that you will be able to collect the power quality disturbance data, and those disturbance data will be put onto the cloud, and with the help of a proper communication and you can take it to a centralized server also and do all your manipulations and calculations, and so that you can estimate the exact problems of power quality prevailing in the system. So the system for PQ monitoring and smart metering has to be considered for giving an internet-based PQ monitoring and smart metering system, because these are the essential ones for accurately helping us in estimating the power quality problems, right? So this is possible only with the help of internet, right? So I think the power quality also we understood by a video, but I can share all the videos to the organizer, Dr. Jagdish, after my lecture, so that he can make use of it. So I told about EN 50160 also yesterday. Hope you would have understood what is the EN 560, but in a nutshell, I can compare this, two standards now. This IEC 61000 series is actually a standard to determine the ability of the device or equipment or system to function satisfactorily in an electromagnetic environment, right? So that without it should not introduce any intolerable EM disturbances to anything in that environment. That is what IEC 61000 series talks about. Whereas IEEE 1159, it is talking about how we are exactly going to monitor the power quality, and it is going to give you the calculations or methodologies to how to monitor electric power quality. It's discussed elaborately in 1159, right? So please follow these standards. As you said, the electromagnetic compatibility is also very, very important along with power quality. Why? Because the emission device and the device, let us take two devices. One is device 1 and device 2. So from the device 1, there will be some radiations which will affect the device 2, because that is a EMC victim device. Same way, the EMC source should be affecting the device 2. So there's going to happen a radiative coupling and a conductive coupling is going to happen, and you need to minimize this EMC problems also. That is what this is given to you. And let me see, these are the low frequency disturbances available in the PQ family, which are less than 9 kilohertz. So the dips, sags, momentary interruptions, swells, harmonic distortions all comes under low frequency disturbances. Right? There are steady state power quality variations, that is nothing but the harmonics, flicker, etc. So 61000 standard only, this is how a document looks. IEC document, it has got 6 parts: general part, environment part, limits parts, testing and measuring techniques as a part 4, and how to install and mitigate the guidelines that will be given in part 5, and generic standards will also be discussed in the part 6, right? So I have also elaborated what each of the IEC 61000-2-1 means in a proper way or elaborated. So if you take this an electromagnetic environment, let us take the same system. See, your power station is going to generate your power, and it will be transmitted via the 275 kV transmission lines, and it will be coming to the substation where your 270 kV high voltage is stepped down to 11 kV, and further what happens, it is being transmitted to the distribution transformer. So from the distribution transformer, what is exactly happening? 33 kV to 11 kV is happening. So suppose your consumer is going to demand for 11 kV power supply, they can very well take the 11 kV, maybe an industrial customer, right? But when you want to take it to home, so you try to again step down to 11 kV bar, 0.415 kV. Take it to the consumer. I think somebody is talking behind the, maybe who is it? Can you turn off your mic? I think somebody is Umakant. Mr. Umakant, can you turn off your mic? Or you can remotely turn it off. So kindly turn off your mic, Mr. Umakant. Okay. Right. Thank you very much for understanding the difficulty. Okay, let us go back. So you see here, we expect a clean waveform, but you see the problems of power quality are prevailing at home, at all the factories. So you need to definitely monitor them, and that is very, very significant in the present environment, right? So this is how your IEC standard document will look, and these are the low frequency conductor disturbances classifications. So IEEE is another important standard talking about power quality, and they classify the power quality disturbances as conducted low frequency phenomenon, radiated low frequency phenomenon, conducted high frequency phenomenon, radiated high frequency phenomenon, electrostatic discharge phenomenon, and also in discharge from nuclear electromagnetic impulse phenomenon, right? So this is the semi FFT curve for electromagnetic environment for voltage sag. And if you see here, your 5 to 10% per site can happen only within this region, right? And your 10 to 15 events can happen within the 70% nominal voltage, right? In a 25 to 30 events can happen in the 90, that is the nominal voltage in the 90. So this is within this window only your disturbances should fall. If it goes above, which then it is violating the standards, and you say there's a serious problem of voltage sag happening. So if you take what are the EMC testing standards, I am talking EMC along with power quality. Whenever power quality problems are discussed, EMC is also very significant because they all come under the family of power quality. And one more member in the family, same family, is earthing and bonding. All the three things should be go hand in hand so that the system is healthy. Our power systems network should has to be monitored for power quality, also for EMI EMC compatibility. Then the system should also have a good earthing and bonding requirements. So if all the three are attacked, definitely you will get a very good PhD thesis, right? So for the sake of researchers, I'm giving some information, so please make use of it, you can elaborate this, and you can definitely produce a very good research, because today presently the papers are getting accepted provided you have a hardware, and IoT based PQ monitoring will definitely fetch you a lot of good papers in the refereed journals, right? Okay. So the EMC are due to two different types. One is interference, another susceptibly based. So see, in the susceptibly based, your voltage shifts, voltage dips, short interruptions, and voltage variations are coming into picture. And for interference based, you are having the conductor and radiated emission, and harmonic current emission, and voltage changes, fluctuations, and flickers are also come into picture. So that is why this is put. So this is how the first page of the standards will look like. So whenever you're dealing with power quality, you must have some fundamental knowledge about the standards of power quality. That is the reason why I have put the first page of the standards, so that you all please go through the standards before you start your power quality monitoring and assessment. Okay? And a very important message I am conveying is, you have to use only class A equipment for power quality assessment. That is very, very important. Class A meaning the sampling rate is very good, 256 samples per second. So that is the most there is a prescribed one given in the standards. As per it, you have to use class A for monitoring the power quality equipment. So this is with respect to IEC I'm talking. So I'm skipping these things, and this is the recommended practice for powering and grounding your electronic equipment. So this book it's called as Emerald book. And it is going to describe how many types of power correction devices that can be accepted in an electrical power in whatever form it is available, and you can how to modify the power to improve the quality or reliability required for the electronic and voltage sensitive equipment. So this document is very important document, which is actually recommending the proper grounding practices so that you can minimize the equipment maloperation, as well as you can also prevent the high ground current. So we put now a classification table. These are the power quality problems, and these are the technologies available. Yesterday we rushed through some technologies like StatCom, DVR, shunt active filter, series active filter, unified power quality conditioner, UPS, etc. So for each of the disturbances listed here, transient voltage surge, noise, notches, distortion, sag, swell, under voltage, over voltage, momentary interruption, long-term interruption, frequency variation, you could see what are the promising power conditioning technologies available. So let us take a random sag. For sag, as a thumb rule, it's a voltage related issue. So you need to have a voltage regulator. So can you see this box is highlighted here. So next box is also voltage regulator. So that box is also highlighted. But motor, generator, yes, the motor and generator also you can not over excite it, right? You can use an AVR to maintain it, but your standby power can also be provided, so that you are going to give whenever the low voltage is coming, you're going to turn on your DG or something, so that your voltage profile is maintained. So you just example is given to understand this table. So all the four categories should be available, so that you will be able to maintain the or alleviate the problem of voltage sag, right? You will be alleviating the problem of voltage sag. Okay. So this is a semi F47 system approach. This is actually addressing the voltage dip at different levels, right? So at the utility end, you apply semi F50. At the facility system, you are going to apply the semi E51 and semi F49 standards, so that the facilities are going to do the PQ monitoring and conditioning effectively. At the destination end or the process equipment end, you will be applying semi F42 and semi F47. This is according to Power Standards Laboratory. Please go through this. Sir, class very urgent. So you have to follow this 3 standards when you talk about the voltage dips. So that's why I'm elaborating one of the power quality disturbance at least to you, so that this will be a carry home message that you must do power monitoring and conditioning at the sending end, at the transmitting end, at the receiving end also. So according to the, you please visit Power Standards Laboratory. There is a PQ toy developed by the Power Standards Laboratory CEO. It's a very good toy for understanding the power quality in a better way. So this is with respect to, again, the types of disturbances, what is the acceptable limits for each of the disturbances. So in order to improve the power quality for the sensitive consumers, you must deploy mitigation equipments between the source and the load. That means at the point of connection, you have to deploy your mitigation equipments. What does the mitigation equipment will do? It is going to improve your power quality. Ultimately, it is going to improve your power quality. You also have to do your improvement of equipment immunity. That is very more important. So you could see power quality has to be addressed at all the ends, supply end as well as at the load end. But in the present scenario, what is happening? They say at the generating end, mostly the power quality is good. Sometimes it is true only. But suppose you are using the generating end as with the power electronic converters like the renewable energy environment, definitely even at the generating end, there will be issues of power quality. So at the sending end also, you need to have a very good monitoring of power quality, so that you are going to enhance the power quality and give it to the end users or the customers. Customers ultimately should have to have a clean source or clean power supply. So that is very, very important, right? So what are the characteristics for your categories for voltage sag solutions? So this is another interesting slide. If you see the problem of sag, what are the solutions you can provide, right? So also along with the relative cost of the solution, this is also taken from internet. So if you see here, there is you start from the utility solutions, right? So sag normally doesn't happen in the utility, but when the same voltage, when it enters into the plant, there you see the voltage is coming down, the quality of the voltage is coming down. So further it is getting stepped down, and it is going to be given into the group of machines, right? So these machines are going to be the source for the particular supply voltage, right? So they may draw more VAR. So when the VAR is more, it has got a direct coupling with the voltage. So what will happen? It will reduce the voltage. So you need to provide some solutions at the panel feeders as well as also at the machine side also, so that you are trying to have the the voltage sag solutions at an economical rate, right? So this is another good slide telling about how the knowledge of equipment sensitivity is very, very important in giving solutions for voltage sags. So these are the simple 8 solutions which are embedded solutions for voltage sags. So tip 1, use DC supply if applicable. Okay, because sag problem will not come, right? Wire load device in a face-to-face configuration. Then identify and improve the sensitive ice cube relays. Do not use phase monitoring relays or under voltage relays in the interlock circuit. Then install auto restart schemes. Use a semi F47, which we discussed, that is going to come for the power supply. Employ delay tripping for motors, conductors, UV, etc. And you have to do at frequent manner the VFD calibration instead of going for scalar to set the direct fly start mode for or flying start to an automatic mode. So these are the things which you do, which will help you to alleviate the problem of voltage sag in an industrial environment. Okay. So what are the types of harmonic mitigation? We'll quickly recall what we discussed yesterday. The first one are the simple line reactors. They are nothing but called as a blocking filters. What is a line reactor does? It provides a very high impedance path to the passage of the harmonic environment. Suppose you want to filter the 5th and the 7th order. So you design a filter or design a reactor which is going to not allow the 5th and 7th order harmonics. It is going to actually bypass it. Anything, you will be sizing the reactor in such a way XL is equal to 2 pi FL. So in that F, you put it as a 250 Hertz. So if you size it for 250 Hertz, any component, anything above 250 Hertz will not be gone through the line reactor. It's a simple solution. Next comes the passive harmonic filters. Here you actually tune the filters. There are two types here, tuned filters and detuned filters. Normally, tuned filters may create some resonance problem. So it is better to avoid tune to the exact frequency. Why? Because it may create resonance to the natural frequency of the system. Suppose there is a case where the harmonics prevailing in the load is 5th order and you are going to tune exactly to the 5th order. Suppose there is a source which is also going to resonate at with the 5th order, means there will be a problem of resonance and it will damage the system. So what do? They normally avoid tuned filters. They go for detuned filters. So this is also a cost-effective solution, but it is not a dynamic compensation. So we want to go for a dynamic compensation, you have to go for active filters. So what are active filters? They try to estimate every cycle the disturbances. Let us take a small scenario like this to make you understand. I am the source, you are all the loads connected in the seminar hall now. I am trying to give you a clean source, voltage source, but each one of your unique loads situated in my classroom. Each one of you are asking me X, Y, Z currents. Like that, well, let us take few in the group are SMPS, few are what do you call arc furnace loads, few are all printer machines, few are fax machines. Each equipment are going to have different ratings, right? So, and there each one of you are having some kind of a non-linearity embedded into your network. So what will happen when the non-linearity is embedded? You are going to create some kind of a disturbance back into the system. That means I am supplying a sinusoidal voltage source, but you are trying to draw different currents of different magnitudes. Finally, what is going to happen to my voltage quality? That is also going to come down. So as a source, I will be supplying only X, but as a load, you will be asking for X plus Y. So who is going to supply this minus Y? It has to be supplied locally. So at the point of connection, that is where the source and the load are going to meet, that is called as a point of interconnection or point of connection, PCC. You are going to install these harmonic filters. These harmonic filters are going to inject in opposite phase the minus Y. So at the point of common coupling, what is going to happen is X plus Y minus Y. So finally, what is happening? The plus Y and minus Y gets nullified and the source is made to feel that it is only drawing, or it is going to only supply X to the load, and load is also only drawing X from the source. So this is how you are making the system to behave with the help of filters. So that is the behavior of the harmonic filters also. Active filters also going to inject these harmonic components in opposite phase to that point of common coupling, so that your harmonic problems are going to be eliminated. Another simple example is isolation transformer. So these will also try to not take the harmonics onto the system level. So others, there are other zigzag transformer or phase shift transformers or new harmonic traps. They may also be provided, that is called others. So this is how a line reactor will look in the real time. So you can see, so if the motor along with the controller is creating some kind of a non-linearity, you put a line reactor. So the disturbances created from the motor and the controller will not transfer to the up end or the upstream level. So you try to eliminate the power quality problems. This is how a passive harmonic filter will look. It's nothing but tuning of L and C component, and when you tune it or detune it, you are trying to suppress the particular frequency and you are able to eliminate that particular range of harmonics. But active filter is a dynamic range. You can program it for any range, whatever you want. Sometimes there is also a zero sequence filter deployed, and you can see that this isolation transformer is also a very good one, which is going to isolate whenever there's a problem between the load and the source. It will try to isolate and give it, so the problem from the load will not come to the source end or the upstream end. So how to do the power quality monitoring? You have to do the PQ environment and survey and calculations, and you have to do make a note of your equipment specifications and development, and you have to do the facility design and power conditioning specifications. You have to do at the planning stage itself. Then you, at the site survey, you will be identifying the different PQ problems. So your equipment performance will also has to be tested, and then you go for designing of various solutions. And among the various solutions, whichever is the cost-effective solution, implement that for and so that your problem is alleviated. So this is about your how a PQ enhancement will be done in a distribution network. So my presentation is as follows, but it's a very elaborate PPT. I'll be sharing with you guys so that you can make use of it to do some research. I'll be very happy to help you all in your research. If you need any doubts in how you are going to apply IoT for PQ monitoring, please write to me also. I'll share my knowledge so that you can really make some hardware and make a good paper out of this end of the presentation, right? So UPQC we saw yesterday. I also told the significance of monitoring considerations. So let me go on directly to how I am going to integrate the IoT into the smart grid. Okay. So this is another flow chart, how to calculate the PQ. Okay. Okay. All you complete 8 subjects. Okay, I want to come and check. Call panna after. On the paper enter kuduthiru poidu. It's very important, la. I have to. Okay, definitely. Thank you so much. Nane pannidren. So you're going to actually take the signature of voltage and current waveforms and pass it on to the algorithm. So that algorithm will clearly tell which is the problem available. So how IoT can be deployed? You put some sensors for estimating these voltage and current phenomena. So IoT sensors will capture the signature and that information will be passed on to an algorithm in the database and the calculations will be done and the end result will be again indicated via a GUI or something so that you will be able to do the PQ monitoring or assessment in the smart grid environment. Now I think you got some idea, right, how to do it, right? So let me go to these are all the things we discussed yesterday. So I'm just skipping all these things and I will go to that architecture basically. Okay. This also we saw yesterday. So let me come back. This one was the interesting slide. See, I told you all to have a monitoring database and these database can be taken to the cloud also so that any calculation can be done and your customer monitoring system will be every now and then can be easily monitored from a local data analysis and you can take corrective measures very easily if you are going to do such a kind of a systematic approach for the PQ monitoring in a permanent way, right? So you need to have a good power quality analyzer to assess it and this is one video about the power quality analyzer. I will show, I think you have not seen yesterday, but I don't know whether you will get the voice of it. That is another problem, but just see the video alone so that I will share the full video to you so that you can make use of it at the later end. So this is one important product from Fluke.
Introducing the Fluke 438 Power Quality and Motor Analyzer. The Fluke 438 is a multi-purpose test tool designed to improve troubleshooting on electric motors and minimize downtime. Whether you're in a process plant or discrete manufacturing, electric motors are critical to your operation's success. The Fluke 438 lets you quickly gauge electrical performance, power quality, and mechanical performance of industrial motors. Using three-phase electrical measurements on the input and motor rating plate data, the 438 calculates torque, the most critical mechanical performance variable, speed, load on the motor shaft, and overall efficiency without the need to install mechanical sensors. All this with a single tool, and all while the motor is running so you don't sacrifice uptime. Power quality issues such as unbalanced and harmonics can cause motors to run hot, eventually stressing windings and accelerating failures. Motor failures lead to costly downtime, and the cost of waste associated with inefficient motors adds up. When testing direct online motors with the new Fluke 438, you get both power quality information and mechanical performance data in the same test with a single tool. With an intuitive user interface, optimized current probes, and at-a-glance motor status screens, the Fluke 438 gives you the motor troubleshooting information you need to make better maintenance decisions and keep your plant up and running. Contact your local Fluke representative to learn more.
So this is one very nice power quality analyzer, but there are so many more are also there, like grenades, etc., etc. So I think you got some idea about the power quality monitoring, how it is done. I will also now tell you, we have actually made one book, right? I will tell the name of the book. Please note down. It is Artificial Intelligence Techniques, actually. I will try to show to you so that you can make use of this book also for your further understanding of on BMS, Artificial Intelligence Techniques. Intelligent techniques for electric and hybrid vehicles. Electric and hybrid vehicles. This is our book. We have written a chapter in this book. You can very well actually go through this for further understanding of IoT based BMS. I hope you can see the window. So in this is the books published by Wiley. You can in this we have contributed this chapter, IoT based BMS system for hybrid electric vehicles. So I spoke some ideas about the battery configurations and the types of batteries for HEV and electric vehicle are discussed. What are the functional blocks of BMS is also discussed. Components of BMS system also can be gone through, and finally I have given some idea how you can apply IoT based battery monitoring system. I hope this will be of great use to you so that you can really make use of the lecture as well as this material, right? So let me go on back to the presentation. So this is a tool, right? So there is also an advanced PQ analyzer also. There's one more tool. That also please go through it. Okay. So this is what we have discussed, right? So time when more things connected to internet than people, that was the Internet of Things, right? Cloud computing made it possible, and internet was also making us to help to achieve our goals. So cloud computing is going to actually do two things: development of self-contained components and delivering these components as services. So that's why we are able to use them like a mobile network as by paying per use, or you are going to provide resources to scale up or take away resources to scale down, or actually for your need you can do it. So this Internet of Things is going to really make it possible our approach, and cloud is actually the IoT facilitator, right? And that is going to help us in all our endeavors. For all these things, you need to have a very good sensor, and this sensor is nothing but going to typically measure or identify the physical quantity. In our case, the physical power quality disturbances, right? So what does the sensor does? The sensor will convert the physical properties to electrical signals understandable by machines, right? So that is what the role of sensors. Sensors are everywhere. Even in a phone, you have a sensor. Am I right? Your phone is trying to open itself. If you show your face, there's a face sensor, right? Similarly, in a petrol bunk, you can refill the petrol unless the operator is giving some information. The sensor is directing it, and you are able to refill the petrol. So everywhere you can use it. So this is the basically the components of IoT, which you would have learned since the past 3 days. So I'm not going to iterate more on it. So this is how your IoT component looks, and you are going to write your algorithm in the application domain, and you're going to extend it for your usage, right? So the sensing element will be having an excitation circuit, and it will be also having a digital compatibility and IoT system compatibility, and this is a smart sensor. How it has to work, it is given here, and this smartness meaning it should be passive, it should be active, and it should have awareness, it should have a autonomous also. So this also we saw, and popular fields where IoT is deployed is 100%. You can easily use it for your homes, for your wearables like your watches. No, you are nowadays Apple Watch and MI watches have come. 63% is about with respect to IoT based watches, and smart city 34% is being deployed now. And in smart grid, where we are talking today since afternoon, it is on 28%. And for if you take the connected cars, it is 19% right now. And slowly these percentages will increase, and definitely the IoT will play a significant role in the coming days. And this also is how the IoT system looks. And this is the architecture for smart grid. If you see here, I told two things today: monitoring the battery. So see, you can see very well this PV, instead of PV you can put wind and biomass. So no longer our homes are going to be consumers; they will be becoming the prosumers. So you will be able to take the information and pass it to the gateway, IoT gateway. From the IoT gate, it taken to our edge server. Then it is taken to the utility where you do the calculations. Then it is given to the regulator so that you will be able to deploy the IoT very effectively in all the segments. By doing this, you can have a control over the load as well as to the utility board. Utility can turn on and turn off, or you can even easily turn on and turn off your loads during off-peak time. When there's going to be a peak time, you can switch off your loads, some loads, and you can reduce your tariff. And during your off-peak time, you can turn on your loads and you can make use of it, right? So this is the gateway of building block, and a digital transformation of power systems is explained in this video. I will be sharing this to your organizer, make use of it, right? So this is how the smart power in home starts from, right? Every time they say, no, whatever you do, let us start from home. So the small example you can try today after reaching home also, right? You can buy some few sensors, cost-effective sensors, and monitor your own fridge, TV, etc., etc. Even when you're away from the home, you can monitor what is happening inside the home. So start from home. You try to apply IoT so that that will definitely help you, give you a learning experience, and so that you can extend it to any kind of application. So here you see it in an air conditioner, you are putting oven, laundry machine, etc. Everywhere you can deploy one IoT sensor. So that what happens is, what is the power being consumed and how you can minimize can be easily accessible and understandable, right? So please do this and get back to me with your feedbacks, right? So smart meters are needed, which I told you. I'm not going to iterate it more. And definitely the IoT technology is going to help you in saving the money, because you can know what is happening and what is being wasted very easily. You can account for your energy so that you can minimize the energy loss. Okay, so this is also we discussed. So I'm going to a virtual, like the basic layers, right? I want to go to the integration of IoT into the smart grid. So this is how the traditional power grid was, and this is how the smart grid was. And you can have a two-way communication established in the smart grid environment. So this is the ultimate logic behind it. So I'm not having time to show the video, and this is a very interesting slide I want to tell you. The Singapore is called as a smart nation, and they have deployed most of the concepts of IoT so that they are able to have the initiatives which were done, where have made the citizens to live better, and there is also a possibility that the business is very viable. Sir, Jagdish sir. Okay. Just give me a. I can understand your difficulty, but I'll share all my materials to you. So with Singapore note, I'll wind up my lecture. So if you see, they have adopted the Singapore is a nation where you have seen most of the places in Singapore have been utilized very well with smart intelligent devices, so that it is called as a smart city, right? And there is also an implementation of green buildings in that place. Thereby, you are able to have a what do you call, the life of the people has been enhanced very well in that city, right? In that country. It's a very small country, and everyone should visit Singapore. That is my final suggestion. What you could see, the people are having a quality life. Why? Because they are able to build a better home with a better community. And you can have a lot of savings have been achieved, and that is what's seen in this slide. So they have built, you can please Google it and see, it is Smart Nation Singapore, and this is also taken from there only. Everything is connected via IoT. So you can see a lot of interconnectivity, and the things have become very smarter and effective way, and people are able to assess the energy loss, etc., etc. So I hope I have justified my role as giving two topics since yesterday. One was on IoT for PQ monitoring in smart grid environment, and second one today we are discussed about IoT for battery management system for electric vehicles. Electric vehicle is an emerging area. I wish all the participants try to involve in and do good quality research. Anytime you can contact me, and I'll be very happy to share you my inputs. Is there any questions? You please feel free to talk to me. Purnachandar, Shanti madam, anybody can, please, it's open to you. You can throw some questions towards me, so that whatever I know I will share with you.
Ma'am, then we'll wind up, ma'am, if there is no question.
There is no question, sir. Okay, sir. Hope it was useful to you, sir.
Sure, ma'am. It was very useful.
Okay, okay. Thank you very much, sir.
Thank you very much, ma'am. Thank you, ma'am.
Thank you very much, sir. Sir, I will be sharing my email ID. You can write down to me also, sir, any queries. You can also give your feedback also.